Hi, in this video we will do the partial fraction decomposition of this fraction. By the way, notice that the denominator degree is greater than the numerator degree. And in the polynomial of the denominator, here we have two factors. So here we have a quadratic factor, x squared plus 1, and we have a linear factor with degree 2. So here minus 1 is a root of the denominator with multiplicity 2. So for that we have the decomposition is on the form a over x plus 1 plus b over x plus 1 squared, because here we have x plus 1 squared, plus cx plus d over x squared plus 1. So here we have a quadratic factor, so we have cx plus d. Here we have linear factors, so here we have a constant a and b. Our challenge is to find a, b, c, and d. So we will give the constant by the easiest way, by giving the easiest equation. So we need 4 equations because we have 4 unknowns. First of all, we will focus on the constant b. So we multiply f of x by x plus 1 squared. So here we simplify by x plus 1 squared. We get this fraction equals, here we simplify by x plus 1. So we get a times x plus 1. And here we simplify by x plus 1 squared. So we get the constant b. And for the last fraction, so here we multiply this fraction by x plus 1 squared. This equality is true for all real x. So when we take x equals negative 1, so this is 0 and this is 0. So b is equal to this fraction, which is x plus 1 squared times f of x when x approaches negative 1, so equals 2 times minus 1 minus 2 over minus 1 squared plus 1, which is minus 4 over 2, so b equals negative 2. Now we multiply the fraction or the equality by x, and we will focus on the constants a and c. And we will do the limit as x approaches infinity. So the limit of this fraction is 0, because here we have the highest degree is 2x squared, and here the highest degree is x on the power of 4. So here the limit is 0. And here ax over x we gives a. So the limit is a here. And here the limit is 0. And here the limit is c. So when we approaches x to infinity, so the limit of this fraction is 0, equals the limit of this fraction is a, plus the limit of this fraction here is 0, plus the limit of this fraction is c. So here we get a equals minus c. Now we have only 2 unknowns, c and d, because we have b is negative 2 and a is minus c. So how many equations we need? We need only 2 equations. So here, when we take x equals 0, so this equality comes negative 2 over 1 is negative 2, and here equals negative c or minus c over 1 is minus c, and here we have plus negative 2 over 1 because x equals 0, so negative 2, plus here we have c times 0 is 0 plus d over 1 is D. So here we have C equals D. Now when we take x equals 1, we get for this equality, so here 2 minus 2 is 0, 0 over anything is 0, equals negative c over 2 plus negative 2 over 1 plus 1 squared. So we simplify by 2 here, plus c times 1 plus d over 2. So this gives d equals 1. We have c equals d and d equals 1. So c equals d equals 1. And we have a equals minus c equals negative 1. Now we have all the unknowns. A is negative 1, c equals d equals 1, and we have b equals negative 2. So the partial fraction decomposition of our fraction is this decomposition. So equals negative 1 over x plus 1 plus negative 2 over x plus 1 squared, or minus 2 over x plus 1 squared, plus x plus 1 over x squared plus 1. So here we have a is negative 1, b is negative 2, c equals 1, and d equals 1. Let's summarize. Here we need to find the four constants a, b, c, and d. So here for b, we multiply f of x by x plus 1 squared, and we take x equals negative 1. So we get 2 times negative 2 minus 2 over 2 equals negative 2. The limit of x times f of x when x approaches infinity equals 0 here and here 0. So we get a times x over x, we get a, and c over x squared we get c. So we get a plus c equals 0. Now when we take x equals 0, we get c equals d, and for x equals 1 we get d equals 1, and we get all the four unknowns. So b equals negative 2, c equals d equals 1, and a equals negative 1. In the next video, we will do the partial fraction decomposition of this fraction, and we will find a, b, and c. Thank you for watching, and see you next lecture.